Hi guys, welcome back to my channel. In this section, I'll be taking you through a problem involving arc length. In our previous lesson, I showed you how arc length formula was proved and we solved a problem. So in this section, we continue by solving this problem here. It says, determine the length of the curve x is equal to 1 out of 2 multiplying y squared for the interval x is greater than or equal to 0 but less than or equal to what? 1 out of 2, and we have to assume that y is positive. Okay, we have to assume that y is positive. So as I gave you the formula for arc length in the previous lesson, let me revise you some more. So I gave you that for the ds, arc length generally L is equal to dx, integral of what? Dx, right? But dx is going to be the square root of 1 plus dy over dx all squared dx, or we can have our dx to be equal to the square root of 1 plus dx over dy all squared dy. So looking at your function, the function will influence either to use the s as this or the s as this. In all cases, you can modify your function to choose the one you're convenient with. But the nature of our function says x is equal to 1 out of 2 y squared, which is in the form g of x is equal to what? Y. Sorry, g of y is equal to x, or x is equal to g of y, a function of y, because we are taking the input of what? Y, meaning y is the independent variable here. Okay, therefore we should go by this formula. Okay, so always all that we need is to choose the ds we want, then after we look out for the parameters within the ds formula. Here we need dx over dy, right? So straight away my dx over dy is equal to this place. If you have a function x is equal to 1 out of 2 y squared and you want to find the dx over dy, what are you getting? You're going to get y. Is that not it? We just get simply y. Now at this point, the next thing that we are supposed to do is we put our y into this formula. Is that not it? So we're going to get our dx to be equal to square root of 1 plus what? Y squared dy. But ask yourself, how can we integrate this expression, right? This expression cannot be integrated just so simple as you know, because you can't use substitution or anything, right? So here we apply the trigonometric ratios, okay? And what you're going to do is you make y to be equal to tan theta, okay? So this makes integration quite difficult. So you just make this y to be equal to tan theta, then that we make substitution here. So if we've made substitution with y, then meaning that you have to change the dy here. Therefore, our dy, what is tan theta? I mean, when you differentiate y with respect to theta, you realize that you'll be getting what? Sec squared theta. Sec squared theta. So here we have changed the y variable here to what? Theta. The y variable here what? To theta. So here we took the y over the theta. So this is it. So our dy then becomes sec squared theta d theta. Okay. At this point, you just make your substitution. My ds becomes square root of 1 plus my y is tan theta. So tan theta squared, right? The y becomes what? Sec squared theta d theta. So you realize that 1 plus tan squared theta is the same as sec squared theta, right? So you have square root of sec squared theta multiplying sec squared theta d what? Theta. And at this point, I can have square root of this to be what? Sec theta, right? Sec theta. So I'll have sec theta multiplying sec squared theta multiplying the theta to be equal to my dx. Okay, this gives me what? Sec cube theta. Sec cube theta d theta, right? That becomes my dx. Once I have my dx, the next thing is so simple. I move towards my integral. But here, what will be the limit for integral? Remember that the interval given was on the x-axis. They said x is greater than or equal to 0, but less than or equal to half. Meaning we have to find the corresponding values in what? In y. So how do we get that? How do we get the corresponding values in y? So here, from the same formula, we have to make x and y the subjects here, right? So if you have x is equal to 1 out of 2 y squared and they said x is 0, meaning once x is 0, my y will be what? 0. Is that not it? Then when x is half, what am I getting? So when x is half, you're getting half here is equal to half y squared. Half and half will go. Then the square root of what? I'll take the square root on both sides. I'll be getting plus or minus 1. Once you get plus or minus 1, then you remember that the question restricted you that assume y to be positive. Therefore, y will be equal to 1. So meaning our limit of integration becomes 0 to 1. So 0 to 1 sec cube theta theta. Then at this point, as I said, this integrate an application of integration. We are not here to integrate, but we're here to apply the integration. So try and figure out some of the terms. I'll be skipping parts, otherwise I'm going to spend a lot of time integrating this. So once I get this expression, I know that my y is what? 0 to 1, right? But now we have left the y domain. We are now in theta domain. So meaning that we also have to shift all the way from y to theta domain. But what is my y? Remember, my y is the same as what? Tan theta. So if I have y to be 0, then what angle of theta will give me 0? That is because 0. So meaning my lower limit will still remain 0. But coming to my upper limit, 1 being equal to tan theta. Remember 1. So tan of which angle will give us 1? Obviously pi on 4, right? So we're going to clean the 1 here. Then we're going to get pi on 4, right? So now after doing our integral, you are expected to get the expression 1 out of 2 multiplying sec theta tan theta plus the natural log of sec theta plus tan theta. Then the upper and lower limits set in, right? Upper and lower limits will set in here. So our upper and lower limits, which is 0 to pi on 4, 0 to pi on 4, right? So once we put in upper and lower limits, we are expected to get our final answer to be equal to 1 out of 2 multiplying square root of 2 plus natural log of 1 plus square root of 2. And that is the length of the arc. Thank you for being with me in this video. Don't forget to like, subscribe, then you share.